question says solve for x, what it's saying is get x all by itself. So if we follow Bedness backwards, Samdeb, the easiest thing to do would be to subtract a term from each side as our first step. So if I subtract b on the left, I'll subtract b on the right. I'll get ax equals c minus b. Then to get x all by itself, I can divide this side by a, and I can divide the other side by a to keep things balanced. I'll get x equals c minus b over a, or the same thing can be written this way because both the numerators are being divided by a. We could look at it that way. This question asks us to solve for little a. So to get little a by itself, I need to get rid of the b, the c, and the 3. If I multiply each side by 3, I can clear the denominator on the right-hand side. And I have 3a equals a plus b plus c. Now, to get little a by itself, I will subtract b and subtract c from each side. And I have my solution. It means the same thing if I write it this way as if I write it this way. Another way someone may have looked at this question would be to separate each term. Then, to get little a by itself, you could subtract the two terms on the right-hand side that don't contain the a. And then finally, to get a by itself, multiply each term by 3. And again, another possibility could be to have your equation written with your b and your c in a different order. For example, like this. To solve for c, we need to isolate c, but here we have c on the denominator. So probably the easiest thing to do would be to multiply each side by c to get rid of having any fractions. C cancels with c, and we have CQ equals 100m. Then, to get the c all by itself, we can divide each side by q, and we get c equals 100m all over q. This question is similar to the previous one. To isolate I, the easiest thing would be to multiply each side by I. When we multiply each side by I, we get rid of the I in the denominator, and we have EI equals 9R. Now to get that I by itself, we divide each side by E, and the E's on the left will cancel, so we have I equals 9R divided by E. In this question, we're being asked to solve for f, but what we'll see here is that f is connected to that negative d out front. So we're going to use the distributive property to separate the two terms inside the bracket from being connected to each other. So negative d times e would be negative de, and then negative d times f would be negative df. Now, in our efforts to get f by itself, we can add a term to each side. We could add de to this side. But if we add de to the right, we have to add de to the left. So now we have a b minus c plus de equals negative df. And then to get f by itself, we want to divide by negative d. So we have our solution here. Now, you'll want to notice that there are a number of different ways that the answer on the left could be written. So I'm going to write it like this and show you with a different color. The a outside of the b minus c could be distributed throughout, and you might see a solution written like this. You might also see that someone doesn't like having a negative value in the denominator, and so they would move the negative up to the top and change the sign of each term in the top. Someone else might break up each of the terms in the top and write their answer like this. But when they do that, you can see that the negative dE over d could actually be simplified. The d in the numerator would cancel with the d in the denominator, and you would have just negative e. So all of these different ways of writing the equation on the left are all correct. It's just a different way to express the solution, and all of them would be acceptable. For this question, we want to solve for little a, so we can subtract a term from each side as a good starting point. So if we subtract b squared from each side, we would get 2a squared equals c squared minus b squared. Then we could divide each side by 2. And we'll have a squared equals c squared minus b squared over 2. And then last, because we need to get rid of the squared with the a, we'll take the square root of each side. Squaring and square root are opposite operations, so we get a equals the square root of c squared minus b squared all over 2. In this question, we want to solve for I, so we want to get I all by itself. So we have to get rid of 2 pi, the g, and the square root sign. So doing SAMDEB, the easiest thing to do first would be to divide each side by 2 pi. There are no terms that we can add or subtract from each side. So I'm going to divide by 2 pi on this side and divide by 2 pi on this side. I get t over 2 pi equals the square root of I over g. Now, I have I over g underneath the square root sign. There's nothing I can add or subtract from each side. I can't simply divide each side or multiply each side by a term because now I'm at the point of the square root symbol that I have to deal with. But if I square each side, that will get rid of the square root sign. So I'm going to write each side. I'm going to square the right-hand side, but then I have to square the left-hand side to keep things balanced. So I have t over 2 pi squared equals I over g. Squaring and square root are opposite operations. Last, to get the I by itself, I'm going to multiply by g on the right, but if I multiply by g on the right, I have to multiply by g on the left. Now this could be written a few different ways. Again, the solution. If someone chose to expand, they would have g t times t at the top would be t squared. And then on the bottom, 2 pi squared would be 2 pi times 2 pi, which would be 4 pi squared. So there's a few different ways that this could be written. This question could be solved a number of different ways when trying to get f all by itself. So I'm going to show a couple different techniques. First, what one might do would be to see that every term is being multiplied by, on the right-hand side, is being multiplied by 5 over 9. So we need to get rid of that 5 over 9 that's being multiplied through. So one method might be to multiply each side by 9 over 5, the inverse of 5 over 9. Because if you look at that, 9 times 5 is 45, 5 times 9 is 45, 45 divided by 45 is 1. So that will cancel out that fraction on the right-hand side. So we can multiply by 9 over 5 on the right-hand side. But if I do that on the right-hand side, I have to do it on the left-hand side as well to keep things balanced. So what happens is that's gone. We have 9 over 5c equals f minus 32. And then to get f by itself, we'll add 32 to each side. And that is our solution. Now, someone may have looked at this question and decided to simply multiply by 9 on each side. And that will work too. We'd have 9c equals 5 times f minus 32. Then we divide each side by 5. So it's just taking a little bit longer. And then we would add 32 to each side. To solve for little r, we need to get rid of pi, capital R squared, and the fact that there is a negative sign in front of the little r and a square root beside the little r. So we will follow Sam Deb. I'm going to divide each side by pi so that I get just r squared minus r on the right-hand side. Okay, r squared minus r squared. Now I want to get rid of the capital R squared, so I can subtract that term from each side. So they cancel. I have a over pi minus capital R squared equals negative r squared. Now I need to take the square root of each side, and I need to get rid of the negative sign. So before I deal with square roots, I first deal with, is there anything I can multiply or divide from each side? So I can divide each side by -1, or multiply each side by -1 to get rid of the negative on the right. So I'm multiplying this first term by -1, and I'm multiplying this term by -1, so the signs change. Then I multiply on the right by -1. Now I'm almost done. I need to find the square root of each side to get my answer. So I write everything just as it is on the left, but the whole left-hand side, I'm taking the square root of it because I'm taking the square root of what's on the right in order to get r by itself. So my solution is negative a over pi plus r squared, all under the square root sign. And someone might choose to write it this way, with the r squared first, minus a over pi. That's probably better form, because we have the squared first, and we're subtracting after. As long as you're isolating a variable and getting it by itself, I'm not going to expect just one way for it to be written. This question looks pretty fantastic, actually. It says solve for e, and you've got e all by itself already. So actually that's a typo. It was supposed to be solve for little m. So let's do that. If we want to get the little m by itself, one thing we see here is we've got two little m's. So we somehow have to rewrite things so that we only see one m, one little m. So if you think back to the distributive property that we learned earlier, where if we had two terms in a bracket, we would multiply each term inside by the value out front, and we would get 2a plus 2b. What we can do is also think of doing that backwards. So if we wanted to take this form here and take a value out of it, we could divide by 2 and have the same thing this way. So that's what we want to do up here with m. We want to have just one m that we're seeing, so we're going to divide each term here by m. Let's give that a try. We'll have e equals, so we're going to take the m and put it outside of a bracket. We have 1/2 v squared, because m times 1/2 v squared would give me 1/2 mv squared. So I've just divided that first term by m and taken it outside of the bracket. I can do the same thing over here. If I divide by m, I get gh. Now looking at my equation, I've got e equals m times a whole bracket. So I can simply divide each side by that bracket. The numerator cancels with the denominator for that part, and I have e over 1/2 v squared plus gh equals m. Now there's a few different ways that we could write what we have on the left, where we could rearrange this information, but if you are able to go that far, that's fantastic. And you don't have to rearrange it at this point in your math career.